is what we call as half the limit property. So this is property number 6, I believe. Okay. This is called half the limit property. Half the limit property. So this property says if f of x is a function defined from 0 to 2a, okay, then integral of f of x from 0 to a is given by integral of f of x from 0 to a plus integral of f of 2a minus x dx from 0 to a. Okay. So how do we prove this first? Let me prove this mathematically. So let me start with the left hand side. This you can always use the splitting of the limit property. So you can limit it from 0 to a and then from a to 2a. Correct? A to 2a. Let us not disturb this one because it is already present in your given expression. So do not disturb. Okay. Here what you can do, you can take your x to be 2a minus t. That means your dx will become negative dt. So f of 2a minus t dx will become negative dt. Now what about limits of integration? When x is a, t is a. And when x is 2a, t is 0. Okay. So 0 to a f of x dx plus this. Now change the upper and the lower limit position and absorb this minus sign. So when you absorb the minus sign, it becomes plus 0 to a f of 2a minus t dt. And as you know, there is nothing in the name. This t can be replaced back with an x. And there you go. This proves your given property. Okay. Right. Now, many a times you'll see some books, they will write it like this: 0 to a f of a minus x dx and 0 to a f of a plus x dx. Please note, this is another formula for integral from 0 to 2a f of x dx. Basically, I've applied King's property on this. So I applied Kp on this and I applied Kp on this. Okay. So you'll find this property also written in some places. Is that fine? Okay. Now let us prove this graphically. Let us try to prove this graphically. Graphical interpretation. Graphical interpretation. So if you want to integrate a function from 0 to 2a, let us say this is my graph of the function from 0 to 2a. Okay. So you're looking for the area below this function and the x-axis if you want to evaluate this. Now this property says you can split this first of all area like this. Only take half the graph. So only till point A you take. Okay. So till A, this area. Okay. This will give you the integral, or this will be equal to the integral 0 to a f of x dx. Okay. And now integral of f of 2a minus x. So how do you first make the function f of 2a minus x? F of 2a minus x can be obtained first by making f of minus x. That means you're
replacing that with 2a minus x.
So you're reflecting the graph. I'm sorry. You're reflecting the graph about y-axis, and then you are changing your x with x minus 2a. That means you're shifting it right. Okay, I'm assuming a is positive here. I'm shifting it right by 2a units. So as a result, the graph becomes like this. The graph becomes like this. Okay. Okay. Anyways, now this function graph, you are integrating again from 0 to a. So you're finding this area. So this area is 0 to a f of 2a minus x. Now it is very obvious that this region area will map to this region, because of course you have the same function and you're integrating it from 0 to a here, 0 to a here. Now this part is basically flipped, right? It is flipped. So this entire area is flipped about the x equal to a line, and hence it becomes this part of the area, which is exactly mapping with the second one. So second one maps with this part, and hence 1 plus 2 will give you this area. Is that fine? Any questions, any concerns, please do let me know. Okay, good. Now, what are the conclusions? I don't have much space. I'll let it over here. So what are the conclusions from this property? Most people remember the conclusions. So conclusion one is, if your function happens to show this nature. Now remember, any function which shows this property will be symmetrical about x equal to a line. How? Very simple. See, what you're trying to say here is that the value that the function has at x, let's say x is 0, the same function it will have at 2a. Let's say this is your 2a point, correct? So if you put 0, f0 will be f2a. If you put 1, let's say f1 is somewhere over here, then f of 2a minus 1 will also be like this. So this trend will continue till it, f of a will become f of a. So basically the graph would be symmetrical about x equal to a line. So anyways, this is a very important functional equation. I am sure if you have seen the video which I shared with you on functions, I discussed about this as one of the functional equation which normally JEE asks. So if f of a is equal to f of 2a minus x, remember the graph of such a function will always be symmetrical about x equal to a line. Now if you put a as 0, automatically this will become your even function, because f of x will become f of minus x. That means the graph will become symmetrical about x equal to 0 line, which is your y-axis. So this is in sync with what we already know. Okay. So what does this property say? So if you want to integrate this function from 0 to 2a, you can just integrate the function from 0 to a and double the answer. In short, what is happening is that this guy will become again f of x. So it is f of x 2 times coming up. So this is how the property gets converted to. Okay. Is that fine? Any questions here? Any questions? Any concerns here? Okay. Conclusion number two. If your function is exhibiting this criteria that f of x is negative of f of 2a minus x, okay, when a function exhibits this criteria, remember, then it becomes symmetrical about a comma 0 point. See why it happens like this. See, let us say this is my coordinate axis. So what value it has at 0, the negative of that value it will have at 2a. So let's say it will have a value here. Okay. Whatever it has at, let's say 1, the same negative value it will have over here. So ultimately what will happen, the graph of the function will appear to be like this. Okay. So whatever is this part area, that would be compensated, or that will be annihilated by the lower half. So if this is positive, this will become negative, and if this is negative, this will become positive. In such case, your function has to pass through 0. Okay, remember, the function will pass through 0, because then only f of a becomes negative f of a. So f of a has to be 0. So in such cases, your integral will actually become 0. Now, very much like the same even odd property, is just that now everything appears to be shifted a units to the right, isn't it? Correct?
Yes, sir.
So in even odd property, your x equal to a was your x equal to 0 line, and your function was f of x equal to f of minus x. In the second conclusion, f of x was equal to negative f of minus x. That means your function was symmetrical about origin. Okay, so end result doesn't change. So even if your function has shifted by a units, the property doesn't change, the area doesn't change. Okay, so let's take questions on this. These are some simple school level questions that can be asked to you. I would like you to do all of them. Let's do all of them. Okay. First one. YPR people, please share your question paper with me. Just want to see how was this question paper.
Okay, sir.
Yeah.
I didn't take photo of the 1 markers though.
Don't you download it on the system?
No, sir.
Why?
We have it in.
Sorry, I
Sir,
lost
they
you.
give it to us in an assignment section, sir, which we can access any number of time.
Yeah, that's what. You can download it also.
That's why we don't download.
Okay, okay.
Oh, we get all the other assignment sheets now are given there, but then for us, exams are conducted in exam.net.
Acha, okay, okay. Because I think NAFL also does it on MS Team assignment part only.
So they are allowed to take photos, I think.
No, you can't touch the phone.
We tell it. I took it that day. Yeah. Okay, whatever.
I'll share this video with your school teacher. Yes, sir. First one done. First one is a Halwa question. 0. Yes, answer is 0. Yeah. So what you do is you realize that if f of x was your cos to the power 5, the moment you do cos of 2a minus x, 2a here is 2 pi. So you will realize you get cos to the power 5 2 pi minus x. Okay, which is actually minus cos x, isn't it? Hey, one second.
Why, sir?
Sorry. Yeah, which is actually cos x. Okay, so what we can do is we can write this as 2 times 0 to pi cos to the power 5x. Now repeat the property once again. So now let's say this is your function f of x again, and this is your 2a. So now this time f of pi minus x is equal to minus of cos x, or you can say minus cos to the power 5x, which is minus of f of x. And now this becomes a 0 because of the second conclusion. Okay, so first answer is anyways a 0. First answer is anyways a 0. Okay. Next one, this is a very well-known expression. So you should remember this answer once we solve it. Again, remember Telangana people, they will remember it. They're very good at remembering a derived result.
What about inorganic?
I don't know about chemistry, but I've spoken to many of them. They would remember the results of some of the commonly asked or commonly used expressions. This comes quite a lot. Ln sin x, ln cos x. Okay, normally a question comes in school also to prove that ln sin x integral is same as ln cos x integral is equal to, yeah, who will tell me the result? Nobody remembers it. Okay, it's pi by 2 ln half. Okay, so how do I do this? I'll just help you to do this. So first of all, this to this step is very clear because you can use King's property. So if this is I, this will also be I. Correct? Let us add the 2i. So if you add the 2i, you get 0 to pi by 2 ln sin x and cos x will get multiplied because, okay, because your log property says log a plus log b is log ab. Multiply and divide with 2. So this will become 0 to pi by 2 ln sin 2x minus 0 to pi by 2 ln 2. Okay, so I've again used my log properties here. Log a by b is log a minus log b. Okay, this result is quite simple. You can write directly minus pi by 2 ln 2, nothing to worry. Now let us work with this guy. In this guy, we'll put 2x as t. So dx is half dt. So 2i becomes 0 to pi ln sin t half dt. Am I right? Okay. Now, if you treat this as your function f of t, you would realize that f of t and f of pi minus t are same thing. Correct? Because ln sin pi minus t is ln sin t again. So you can use half the limit property and you can say it is 0 to pi by 2, 2 times ln sin t. Okay. 2 and 2 goes, and you can see here that you are back to I. So what has happened here? It has become 2i is equal to I minus pi by 2 ln 2, clearly implying that I is minus pi by 2 ln 2. That is actually pi by 2 ln half. If possible, if you want to compete with Telangana people, what, sir? What is your enmity with Telangana, guys? I'm just joking. So remember this result.
Could you please scroll up?
Sure. Till this point is okay? This point?
Yes, sir. Done, sir.
Done?
So could you scroll down?
Yeah.
Thank you, sir.
Okay, we'll continue with the same question. I'll copy the question once again. I think it was this one. There you go. $35.51, I'll remember it now. Yeah. Third one. Let's do the third one. Third one, remember, there's a square, b square, there's a4, b4, sine square, cos x, sine square, sine square. Sorry, sine square, cos square. Small changes here. I mean, many people will say, is there a Printing mistake, should have been cos square. No, it is actually cos x only. I'll give you the answer. You just tell me whether you have got it. Just say yes or no after doing it. The answer is pi by a square plus b square. Okay, let me also contribute here, because if I wait for everybody to solve it, then it'll be too long. So what I did here, what I will do here, I'll split this as two separate integrals. One being this, and the other being this. Okay. So far so good. No problem with this. Okay. Now, if you see this function, let's say I call this function as f of x. Do you realize that f of x is same as is negative of f of pi minus x? Yes or no?
Yes, sir.
So this entire thing will collapse. You don't have to evaluate it. Correct? In this part, divide by cos to the power 4. Okay, so if you divide by cos to the power 4, you will end up getting a square tan square x secant square x. Okay, or we can do one thing. Yeah, okay, fine. Let it be as it is. Okay. What will happen here? It will become a to the power 4. Or why you are dividing it by this? Let it be as it is. Let's divide by cos square only. So this will be a to the power 4 tan square x plus b to the power 4. Okay. But ultimately you have to multiply with the secant square x. So multiply with 1 plus tan square x. Is that fine? Now, if you take tan x as t, you'll realize that the limit of integration will actually become from 0 to 0. That's something which many people make a mistake. Remember, I discussed this with you. This is something which you are not allowed to do, because at pi by 2, the function shows undefined character for tan x. Okay. So when you're doing this property, I'm not stopping you from doing it. But before that, you need to use your, odd, half the limit property. So what I'll do is, before I move on to do this, I realize that this is a function which is not going to be influenced even if I change x with pi minus x. So let's say if I call this whole thing as g of x, then g of x will follow g pi minus x is g of x, isn't it? Nothing will happen to the function. So first split the limit of, not split, half the limit of this to 0 to pi by 2. Okay, and then put the substitution, tan x is equal to t. So I'll be saving my effort over here. I will directly jump to the result here in terms of t. So this will become 0 to infinity. You'll have a square t square dt by a to the power 4 t square b to the power 4 1 plus t square. Okay. Now I'm sure you all have done partial fractions. Okay. Treat your t square as if it is some y, right? Break it down into partial fractions. So when you break it into partial fractions, you'll get 2 times 0 to infinity. I'll directly write down the result. So it is b to the power 4 by a to the power 4 t square plus b to the power 4 minus 1 by 1 plus t to the power 2. And if you see here, it will generate b to the power 4. So you have to divide by b to the power 4 minus a to the power 4 b to the power 4 minus a to the power 4 and also multiply with a square. Okay, so please do this step at your own end. You don't have to always copy everything from the screen. Okay, so break this up into partial fractions. For partial fractions, I would recommend treat t square as if it is y. Okay, don't treat it as if it is actually a quadratic, because if you do that, you'll get a lot of things as 0 in your a structure of that partial fraction. So since t square is uniformly occurring everywhere, I would recommend putting t square as a y and think as if you are trying to write a partial fraction for something like this. Okay, so I think just a by a to the power 4 y plus b to the power 4 plus b by 1 plus y will be sufficient. Is that fine? Now this is something which we can easily integrate. So 2a square b to the power 4 minus a to the power 4. Integration of this is going to give me tan inverse 1 by b square tan inverse a square t by b square divided by a square. Now why this a square? Because this is reverse chain rule you have to follow. So I think it is all muddled up here. I'll write it neatly. You understood why I have to divide by a square? Because this term is actually a square t whole square, isn't it? Okay, and this is b square whole square. So 1 by b square tan inverse this by b square and divided by a square, because coefficient of t is a square. This is also tan inverse t. Okay, 0 to infinity. Now guys, all of you please be careful here. Many of us blindly write down the answer of this as pi by 2. Please be careful about the sign of the term which is along with t. Now here it is positive, so no need to worry, right? But if let's say there was a by b and I said a and b have opposite signs, then it will become, when you put an infinity in place of t, it will be treated as a minus infinity, and then your answer will become minus pi by 2. Are you getting my point? So let's say you had tan inverse some pt by q, and I said p into q is negative, right? And let's say your integration limit is 0 to infinity. So when you put infinity here, remember, many people don't care about this fact. They think that, okay, tan inverse anything and infinity is infinity, so pi by 2. No, p into q is negative means p by q is also negative. So this will yield a minus pi by 2 when you put an infinity. Are you getting my point? So be careful there. So here I think nothing to worry because they are all positive. So 1 by a square b square pi by 2. This will also be a pi by 2. Okay. So we can take
So there'll be a b power 4.
b to the power 4
x
is also,
values.
yeah, b to the power 4. Correct. Thank you. So this will become pi by 2. You could take common, so it will become a pi, and you'll have a square by b square plus a square times b square minus a square. And down here in the thing, this will become b square minus a square by a square. So this a square will go off. This will go off with this, giving you the answer as pi by a square plus b square. Is that fine? So now, if this property was not there, most of you would have just concluded that it is a 0. But use your common sense. Everything is positive over here. Oh, just cos x was creating a problem, but we changed the problem to this. So everything was positive over here. How can a positive function integration give you a 0 till the function is completely flat? And you know this is not flat. This is not y equal to 0 function. Okay. So please do not jump that, okay, the answer would be 0 over here. Okay, at this step, please do not assume tan x to be t and then write a 0 as your answer. That would be wrong. Fourth one, let's conclude the fourth one also. Put your answer on the chat box for the fourth one. Yeah, done? Okay, the first thing that you would do here is, again, I'll write down the question once again because it is hidden from my normal view. Sine to the power nx, cos to the power 2nx, sine to the power 2nx, cos to the power 2nx. Okay, now everybody, first of all, what is the first thing that comes in your mind when we see this? King's property comes to my mind. So I will be, because I don't want to see this x. Okay, this x will create an issue for us. So the best way to get rid of that x is use King's property. Okay, using King's property. So this will give you 2 pi minus x. Okay, nothing will be affected because they're all raised to the even power. They're all raised to the even power, so nothing will get affected here. But when you add it, you'll end up getting 2 pi this. Now, the moment I see this, I feel like creating a pi by 2 over here, because then sine will become cos, cos will become a sine, and again King's property will do wonders for me, which I can do very easily. First of all, if I treat this as my function, nothing will happen if I change my x with 2 pi minus x. So it is easy to drop this 2 down over here. Even if you replace your x with pi minus x, nothing will happen to the function, so you can further drop a 2. So I will become 8 pi 0 to pi by 2 this guy. Now, I think this is something which you all know how to deal with. Again, King's property. So apply King's property again. If you apply King's property, it becomes 8 pi 0 to pi by 2. Cos will come up and denominator would be unchanged. Okay. Now, when you add them, you know it's going to give you a 1. Okay. So your answer would be 2i is equal to 2i is equal to, by the way, there was a 2i here itself. Okay, so 2, 2, my God, this will become 2 and this will become a 4. Yeah. Okay, so 4i will become 8 pi into pi by 2. That means I will become a pi square. This is going to be your answer. Is that fine? See, remember when you were applying King's property, we added these two. So I got a 2i over here, and then I started dropping the halving the limit. Okay. Now 2i is this again, King property on 2i will give me 2i again. So 2i, 2i, 4i. And this will add up to give you a 1. So 8 pi 0 to pi by 2, 1. And this is 4i, giving you I as pi square. Is this fine? Any question, any concerns? Please do let me know.
No, sir.
Sure, Pakka?
Yes, sir.
Okay. Okay. Can we move on to the next question?
Yes, sir.
Okay. So the next question that I would like you to solve is integral let me check if I have any. Okay. I think we did this question. Would you like to try this one? Okay, let's do this. The C1 is basically a true property because it is basically based on periodic properties of definite integrals, which is applied to periodic functions. So if a function, let's say cos square function, right? Okay, I'll leave up to you to make the assessment. Let's see how many of you are able to crack it. Which of the following multiple options may be correct? Okay, so this is not a single option correct, multiple options may be correct. Done? Not a difficult one. That's correct, Shishti. Very good. Very good, Tripan. Okay, let us discuss this. The first one can be, you can use your King's property over here. So a to pi minus a. Remember this is your a and this is your b, correct? So replace your x with a plus b minus x. A plus b itself is a pi. So you can write this as I equal to a to pi minus a, pi minus x. Sine pi minus x is as good as sine x. So when you add it, you get pi times 2i is equal to pi times 0 to pi minus a f of sine x. Okay. So if you make I the subject of the formula, it will become pi by 2 over here. So obviously option number A is correct. Okay. Now B, this is an even function. Okay. Whatever is the f of x, the moment you square it, okay, so it will become an even function. Now this is this always true? Is f of x whole square always an even function? That is what I want to know.
So for real functions, I think yes.
What if it is root sin x? I'm not sure.
Because of domain of that function, I think it will be still positive.
Okay.
See, you are trying to say that f of minus x either always gives you an f of x or minus of f of x. Is this statement itself always true? For example, let us say I talk about 1 plus sine x function. Okay. And I'm dealing with something like this. If I change my x with a minus x, I get neither of the two.
Oh, yes, yes.
Yeah, we cannot make such a statement over here. Because you don't know what will be the, when you change your x with a minus x, whether it gives you f of x or minus f of x, or it could give you neither also. Correct. So this is a doubtful property. So B cannot be your option. Okay. Now here I was about to tell you something which anyways is a part of your future property which I am going to talk about. F of cos square x will be a periodic function. Now with what period? F of cos square x will be a periodic function. That is undoubtedly true, correct? But with what period? Period means after what change in the value of x will the function repeat itself? Now the problem is many people will state pi.
2 pi, I think.
But it is not correct. Okay, it can be more than pi also, but it depends upon whether f is periodic or not. For example, let us say I give you a function cos of cos x. Let's say I give you a function like this. Okay, let's say I take this as a g of x. Will you say that this function is periodic with 2 pi? Will you say that? It could have a period lesser than that also, because this period, the period of this function is actually a pi, because the moment you change your x with pi plus x, it becomes cos of minus cos x, isn't it? And cos is unaffected, so you get this back. So it is a function whose period is actually pi. Okay, but here there is nothing to worry because f of cos square x period will always be either pi or lesser than that. So this property will still hold good. Are you getting my point? So C is also a right option. But saying that period of f of cos square x is pi, that is not correct. It depends upon your f also. It depends on your f also.
So could you please repeat?
See, I'll give you a very generic idea. F of g of x. If g is a periodic function, let's say with period t, then this will be periodic, no doubt about that, but not necessarily with a period t. Not necessarily with a period t. That is what I want to say. It depends on f
Okay.
actually. Okay, so as you can see here, there was a cos of cos x. The whole thing was not periodic with a period of cos x. Are you getting my point? It also depended on it was actually a pi. Cos x period is 2 pi, but this answer was actually pi. Okay.
Okay, sir.
Okay, so C is correct in the present scenario, and this is basically again you can use substitution here. You can put for D you can put x plus C as a t. So dx will be equal to dt. So this will become lower limit will become a c when x is 0, upper limit will become p, and this will become f of t dt. And there is nothing in the name, so it will become back to x. Okay, so D would be correct. D would be correct. Understood? Any questions? Any concerns? Okay, try this one out. Minus pi to pi 2x 1 plus sine x by 1 plus cos square x. This might not be related to the property that we have just now done, but it is very important question that comes in school exams as well. Okay, that's why I thought I would do it with you. Done?
1 minute.
Okay. Let's discuss this. So first of all, you can break this up as, it's actually based on even odd property. So you can break it up as this and this. Okay. This is clearly 0 because you're dealing with an odd function over here. This is an odd function. Correct? And this is an even function because x and sine x both being odd, the product is even, and cos square anyways, 1 plus cos square is going to be an even function. So you can write this as, you can break it up as 2 times, but there's a 2 here also. So 4 times, your integral will be 4 times 0 to pi x sine x dx by 1 plus cos square x. Now the presence of an x makes us all discomfortable over here. So what we can do is we can use King's property. King's property, we can write it as pi minus x, and I think nothing else will change. So you can just copy it as it is. So 2i, just add them all. 2i will become 4 times 0 to pi. Okay. Pi will also come out sine x by 1 plus cos square x. Right? Now this is a simple problem where you can take cos x as a t. So minus sine x dx will become a dt. Okay. So I will be equal to 2 pi minus, this will be 1 to minus 1 dt with a negative sign by 1 plus t square. So we can do one thing, we can observe this negative sign and flip the upper and the lower limit. So the answer here is 2 pi tan inverse of t from minus 1 to 1. Both will give you pi by 4 minus of minus pi by 4. So that is equal to pi square. So I will be equal to pi square.
Sir, I think there's a 4 pi outside. Oh no. Oh,
No, I just cancelled this 2 and this 2.
okay.
Yeah. Is that okay? Any questions, any concerns here? This is an important question. Please mark it with important as important in school exam. Okay. Now,